We'll look at it all together.
Don't forget your clicker.
You don't forget my clicker.
Ow.
Thanks.
Just kidding.
No, sir.
Come here.
Nope.
Help.
We're about to go over a lot of this as a whole class, and then I'll answer whatever questions I can after class if you still have them, okay?
Definitely
Oh,
go
wait.
over
We switched to.
Which explicit? Really?
Yes.
From the conversations I had, they seem to start to get it. I know 8B was trouble, but...
I'm not picking up.
I would just at least say what all of them are.
Okay. Thank you for that input. Okay, so let's quickly look at A then. Explicitly, we should remember it's all about inputs and outputs, right?
Yes, sir.
So when I think about it that way, f of x, that's an output. Where does my output start?
Right there. 64.
64. And then what am I repeatedly doing to it?
You multiply by 2.
Well, hold on. Let me ask you this. Could you write this f of x is equal to 2 squared?
This one?
Yes.
Well, let me ask you this. Does 2 squared get every number up there?
No. It doesn't. It's kidding. I know for a fact.
Yeah, it doesn't.
No. Now, if you were to ask me, could it be 2 raised to the x?
Yeah. Sorry.
That's a different story. Because I will say, you know what 2 to the 6th is?
36.
Right.
What's 2 to the 7th?
128.
So yes, you can do that. Now, if we're just basing on this table, though, it is easier to say, hey, I'm starting at 64. I'm repeatedly multiplying by 2x minus 6 times, because that's the 6th time. Right? And we cannot forget, Jaleo, how does every recursive equation start?
Equals
F of x minus 1, right? Not parentheses, right, Corel?
Yes.
Yeah, so f of x equals f of x minus 1. So, Kelsey, what am I doing to this previous term?
You're multiplying by itself.
Multiplying by 2.
Oh yeah, that.
Did you say multiplying by itself?
Yes. No, it
You
doesn't
think
work
about-
like that.
Okay. What am I missing from this, though?
Oh, that's what I was talking about. B. B is multiplied by.
No, what am I
itself.
missing from here?
Oh, you're missing
What is it?
The start.
Say it.
Starting point.
Starting point. You cannot have a recursive without a starting point. F of 6 equals
Oh,
64.
64. All right. Quickly doing the linear, then we're going to talk about this quadratic. This is what type of function? Linear. So we've done this a lot, right? What are the 3 main linear explicit equations that we have studied?
Yeah.
What is it? Slope, intercept, point slope, standard. Peyton, can you tell us why we cannot use slope intercept here?
No.
You can't?
Is it because you don't have your answer, but you know what the slope is, though, right?
I mean, if you really wanted to, you could find it.
You could. I do like that. Yes, you could find your y-intercept. But Peyton, do we currently have the y-intercept?
No, we have 6.
Right? We have that input of 6. That's where we're starting. So yeah, we would want point slope. I think a lot of us would have done this as 2 times x minus 6 plus 11.
Whoa.
Okay? I do want to ask you this then. Could I have written this equation, 2 times x minus 7 plus 13? Would that have been a viable or a valid point slope?
Yes.
Why?
Because it makes it true.
How do you know?
It does.
Plug it in.
You could substitute things in.
It's still a solution.
How do you know though? Like without me substituting anything in, how do we know this equation works?
Because I know that there is a 7 as an input, there is a 13 as an output, just like you have.
There is a point 7 comma 13, just like 6 comma 11. That's all I was asking, right? I want you to realize, hey, that's a valid point.
And when you look at that, if you look at it, it's y is equal to m, right? What is our m? It's
Slope.
2, right?
Yep.
And then x minus x, when you have x minus 7. Okay, so what is 7? It's 13 plus 13. Boom.
Good. Devin, How do we always start the recursive equation? How do we always start the recursive?
He said F of X.
Oh, F of X.
F of X.
Is equal to what?
1.
Is equal to 1.
Minus 1.
F of X equal to what?
F of X minus 1.
There we go. There we go. I know Peyton was working hard with you on that. And so what's my rate of change for this one? What am I doing?
You're repeatedly adding 2.
Okay, but Carell, what am I missing? I'm missing something from this equation.
Yeah, you missing F parentheses. I mean F of what was it, 6? And then equals 11.
I'm really proud of you for correcting your language on that. F of 6. Not F parentheses, F of 6,
If I
right?
kept playing around too much, I got stuck in
I
my
know
head.
you playing around too much, that's why I got on to you. Alright, last two things. We're not going to get much more complicated than this. Please remember, the focus of this unit is learning what a quadratic function is. That's it. So when I look at this equation, we're going to have basic explicit equations for quadratics. In this case, just x squared, because what is 6 squared?
36,
8 squared,
64,
10 squared,
100,
9 squared.
91. I mean 81, whatever. it is.
So does every point in this table make this equation true?
Yes.
Does that equation model those points?
Yes.
Now, recursively, I know this is a little bit more difficult, but Chris, how does every recursive equation start? F of x. I got the f of x. What comes next? There you go, f of x minus 1. But after I get that previous term up there, I still need to apply the what?
Current,
The what?
current.
The current is equal to the previous. What do I still need after the
Rate of
previous?
change.
That rate of change.
Oh, right, change.
Right? But what kind of rate of change is right here?
I don't know. A linear.
If it's a quadratic function, it has what rate of change?
A linear.
A linear. We knew it was quadratic because there's a linear rate of change. So we need the equation of a
Linear.
line, right? A linear expression, at least. So one thing I started to do, I can't remember if I showed each of the groups this or not, but I want y'all to notice, can I make a table just for my linear rate of change?
No, yes you can. I'm just going this can.
Right, and this is something that's helped a lot of other students today. Notice my linear rate of change.
713.
Notice the plus 13 led me to that 7. The plus 15 led me to the 8. So that's how we're getting this. So what equation can we use to model these values? Point slope, slope intercept, standard. What is it?
8
Y'all,
plus 2 minus 1.
point slope, slope intercept, or standard?
Point. So,
Why point slope? Why not slope intercept?
I'm not. What?
No,
I have
one
questions.
slope because we have a point.
No, but
I
I
have
have a
a
question.
slope.
What is the slope?
The slope
it
is 2.
Well, remember
Something
slope
like that.
is what divided by what?
Because we have a point and we have a slope.
So my rise is 2, my run is,
1.
We cannot go with slope intercept because we don't have an intercept. However, we do have a.
well, be clear about your language. We don't have which intercept,
The Y.
okay? So, hey, by the way, does anyone recognize this where we have the point 713 and the slope of 2?
No. Yes, right there.
So what is my rate of change? Plus 2 times x minus 7 plus 13.
Y.
Isn't that equation of the line my rate of change?
Yes.
Or that expression? So that's all it is.
Crazy.
Desiree, what am I missing though from this recursive?
I know.
Not sure? I'm going to call on you tomorrow for it. You better remember this. Carell, what are we missing?
We're missing the F. Parentheses, what? 6 equals
What is that, Corel, that you just told us?
That's the,
Shelby, what's it called?
Starting point.
The starting point.
how
You
about-
can't just have the rate of change, you also have to have that starting point. You've identified the correct starting point. Alright, here's your homework.
homework.
It is not much, especially if you did your homework over the weekend. It's just 6.1, go numbers 11, 14, and 16. Alright, if you did your homework over the weekend, you already have 11, 13, and 14. So then we're just adding 16 to that if you did not do your homework